You guys can hear me all the way in the back, even though it's a small room. It will be all right. Perfect.
I'll introduce you if you don't mind.
Yes.
Well, I know you know how the rodeo, but
Well, it's been a while. So.
thanks everybody for coming to the data engineering meetup. So glad you could be here on, it's September, right? Guys, I've had a crazy month. I'm surprised it's not November already. It's just been insane. But I'm so glad you're here. We want to thank Recursion for letting us come here, for giving us pizza. Give them a round of applause. That's Ayla. She works here, and she does all the heavy lifting. I just show up and bug her for a Zoom link incessantly. By way of announcements, we always start, is anybody hiring? And then the room's always silent, but I still want to ask, just in case. Oh, we got some things.
Well, so my company's based in Silicon Valley. They're looking for in-person front-end and back-end React Native engineers. But I work remotely for them, so I know that they wouldn't be opposed if you were an excellent, high-quality engineer. So I posted it on the Utah Forge a while back. But...
Oh yeah, that's the reminder. If you haven't joined Forge Slack, it is the best place. So Forge Utah, we're a nonprofit company for technologists, and we just run tech events. We've got meetups, got a conference next month. Hopefully we paid for a booth at KubeCon, but I don't know if that's going to show up because we don't know anyway, we all have full-time jobs. And then we'll be involved in Tech Week. But if you want to join our Slack and have fun technology conversations, you just go to forgeutah.tech. There's a button right in the homepage that says join Slack. And you join Slack and it'll add you to all the good channels except for the data engineering channel. You have to add yourself to that one. Sorry. Ayla, you had you're hiring? Yeah. You can talk into the mic. Everyone will hear you.
Thank you, Mariah. We're looking for a senior high performance computing storage engineer. Definitely. Yeah, it's definitely a specialized position, but we are actively interviewing for that.
Are you hiring in HR at all?
Senior.
That's a yes. I don't know what that means. I listen to a lot of tech podcasts, and Recursion Pharmaceuticals has shown up on Software Engineering Daily, Software Engineering Radio. They were on the AZ16, which is a VC fund, and they were on one other one. They had the CEO and one of the a VP and a CTO, and I don't know who else. So clearly it's a special company, not just because they give us pizza. Other announcements I always announce the MLOps meetup. MLOps is next week. I think it's NVIDIA performance. I don't know, we changed that one. What was that? The MLOps meetup is advanced machine learning time series forecasting methods. That's what it is. And that's in Lehigh. Do I have any other announcements? No, I talked about joining Forge Slack. Cool. If that's it, that's all. I'm gonna hand it over to Matt, who is a regular that we don't see anymore because he wrote a book and got famous.
I'm also in town a lot more than I used to be over the last year, so that also makes a difference. All right, so I'm going to talk about this notion of a gap between machine learning and data engineering, and feel free to challenge me about anything, because I think this topic is very much in flux, and you may have different opinions just based on what you're actually seeing happen in various industries, both like large traditional enterprises, startups, large tech companies, FANG companies, everything in between. So this is just kind of based on what I'm seeing so far. I think most of us would agree that the industry was pretty shaken up about 2 years ago with the introduction of ChatGPT. And maybe a lot of us started rethinking our lives and our careers. And I think at this point, we probably feel a little more settled, right? Like the job market is a bit shaky. That's fair. Job markets are cyclic, but at the same time, there still seems to be plenty of work for data engineers to do. That doesn't seem to be going away. But what I am going to talk about is the fact that machine learning traditionally has kind of handled its own data separate from data, what we often call data engineering, except at big FANG companies like Google, where these definitely overlapped. So I'm going to talk about some of the reasons why that is and where I anticipate this going, that I think that gap will actually close, and how you want to maybe think about your career in that context. There are actually a lot of different types of work that data engineers can be doing and evolving their careers into. But I think there are very specific ways in which data engineers are going to be contributing to what we now call AI, but really has been around a long time as deep learning and machine learning engineers in very specific ways in the future. Okay, so I'm Matt Housley. Funny thing is, a long time ago, I think it was back in maybe 2018, I was one of the co-founders of this meetup, and since then got busy with a couple of other things, moved away for a while. Now I've moved back, and Mariah was so kind as to invite me to speak this time. So this will be a lot of fun. And I also wrote a book with Joe Reese about data engineering, and we'll be talking about a lot of the same themes that are in the book. And that is, originally in 2022 and now in 2024, how do we even define this discipline that's very much in flux and that's been through a lot of cycles since the 1970s and a lot of changes? Okay, so to talk about this, I'm first going to talk about the story of data engineering. Why would I tell a story about data engineering? Well, if you try to understand what this title even is, you need to look at the places where we've been and the things that we actually do, right? It's the boundaries are so broad that it's kind of a hard thing to define, but we can look at what we've been doing since the 1970s up to the present to just try to define what this discipline is. Then I'm going to talk about the cultural divide between machine learning engineering and data engineering. Then we'll talk about threats to the Gen AI revolution. I think most of these will be pretty familiar to you because they garner a lot of headlines. We'll talk about the limits of current techniques that we're trying to use to combat some of these problems. The basic concept of garbage in, garbage out, one of the oldest concepts in computer engineering. And then we'll talk about the return of data curation and a couple of other ideas. Okay, so this is, as I was outlining this today, this is roughly speaking what I think of as the eras of data engineering. Now, I should clarify that these eras are kind of fuzzy and they overlap in complicated ways. It's not like as soon as we moved beyond we didn't really move beyond relational databases. They never went away, but the emphasis kind of shifted to data warehousing, what we call MPP systems, and then so on. These various eras, the emphasis, the exciting stuff shifted, even though the older stuff remained with us. And I define these very rough, endpoints when these eras started and ended, but there's so much overlap, it's all very fuzzy. But let me talk about what I mean by these different eras. So first, the relational database era. And this goes back to the 1970s, and this really started at IBM. So this old school behemoth, E.F. Codd, worked there and came up with the concept of the relational database, but it wasn't really until Oracle was founded that this became widely used. Like IBM kind of ignored the technology for a while. They saw it as a threat to their traditional businesses, so they didn't move on it. Larry Ellison and Oracle jumped in, and then you see this progression of relational database technologies to where in reality, relational databases are still extremely important in the present, right? In fact, a lot of people say that we're in the Postgres renaissance, that we're like coming back to Postgres as one of the exciting technologies. But you see, yes. Exactly, yeah, Postgres, I failed to even mention DuckDB. That one I didn't throw in. Oh, okay, that I didn't even know. So you learn something at each one of these meetings, even if you're the speaker. But you see this progression, Oracle, then Microsoft gets involved, and then MySQL, now we're going open source or democratizing. And then Postgres, these days Postgres is probably more important than MySQL. A lot of that is due to licensing reasons, and the industry kind of shifted toward Postgres. And then the LAMP stack, so when the web comes around, we could have defined web pages in a lot of different ways, but we ended up building web pages on top of relational databases instead of some other technology. And so what this means is that in this era, if you're going to be doing analytics, you're probably going to start looking at a relational database. In fact, when relational databases came out, they Unlike earlier hierarchical databases, they presented data as rows and columns. And that is a very organically natural way for us to do analytics. In fact, we've been doing analytics that way for hundreds of years, just pen and paper, right? And that's not scalable. So when relational databases became available, that was kind of the beginning of analytics data engineering. It's like now we can take large volumes of data and process it statistically in a very straightforward manner. So you see this progression. And I would say, you know, until through the LAMP stack into the 2000s, traditional relational databases, that's how you did analytics at any kind of scale. Okay, data warehouse era. What do I mean by a data warehouse? I'm kind of playing fast and loose with terms here. Roughly speaking, I mean a dedicated store that's used just for analytics. So now we're going to do things like separate our analytics stores from our operational stores. So we have a separate database just to run large queries. So we're not hitting our main MySQL database, for example, in the LAMP stack that's running our web page. We don't want to slow it down. We're going to separate, and that allows us to scale up. But it turns out that even though I'm specifying this is about from 1990 to 2005, the concept is very old. Why do I mention Teradata? These days, if you worked with Teradata, it's super old technology, right? But that's because they were first. They were the first ones to really build an MPP system. By MPP, what is it? Massively parallel processing. But that basically means you have a cluster of machines that can process queries and store data rather than having a single machine. So they pioneered this idea of a separate store just for analytics clear back in 1979. Then you had a bunch of things that happened, but like at IBM, you had researchers define a business data warehouse, or they called it a business warehouse. And then Bill Inman published his book, Building the Data Warehouse. Already companies were doing things that were data warehouse-like, but it was kind of a manifesto to say, this is what a data warehouse should be in terms of storing data from your operational systems, keeping a record, and also allowing you to do both current and look back analytics. And then Ralph Kimball, shortly thereafter, he has his own philosophy about how to manage schemas, how to manage data in the data warehouse. And the reality is that data warehouses were very important. They're still very important, but I think of this as maybe the dominant paradigm until about 2005. But again, I'm being a little bit flexible here because we'll see some overlapping paradigms. Okay, now let's talk about like web scale and big data. And this term, big data, is kind of out of fashion. It's not really novel anymore to be able to scale up to petabytes of data. But in the early 2000s, that was very hard and very expensive. And in fact, we're going to trace it back even earlier. So people kind of laugh when I recall Alta Vista, very old search engine. If you're of a certain age, then you probably used it before Google came out. But the point is that Alta Vista was the first really successful web crawler search engine. So the thing about the web is that it's basically the world's largest database. You can think of it as just a massive database of all these connected machines. So it's a huge, huge cluster of computing. The problem is that it is a terrible search engine in itself, right? Like running a query across all of the web directly is virtually impossible. There are just too many machines, too much latency to grab data from the individual servers. And so we had to start collecting that data in a centralized way to build better search engines. So Digital Equipment Corporation, which has been gone for a long time, but they pioneered this approach actually just as a demonstration of some of their most powerful servers that they had introduced in this era. The reality is Digital kind of lost interest in the project, and so that allowed Google to jump in. So about 1996, you had this PageRank research that was going on at Stanford University, Sergey Brin, Larry Page, and then they turned that into Google in 1998, and then they quickly realized, first of all, querying the web, even when they started, was really hard, and it was getting harder and harder because the amount of data in this massive database that is the web was getting larger every year, every month even. And so they came up with something called Google File System, which allows you to store data across a lot of different nodes, and then MapReduce, which allows you to basically run queries across all the nodes and then collect the results. So map, run a query across 1,000 nodes, reduce, collect the results afterward into something coherent. And as Aaron says from time to time, any system you look at now is basically MapReduce in some form, right? If you use Spark, it's doing MapReduce with some memory caching. Use BigQuery, MapReduce behind the scenes. We don't really talk about it because it's not novel anymore, but that's where this started. Okay, then we saw democratization. Google was kind enough to publish those results in papers, and Yahoo got interested because they were still like a force in the internet back then and needed a better way to scrape the web. So they started building their own system, made it open source, and everyone started adopting it. Everyone is a slight exaggeration, but how many of you have worked with Hadoop at some point in your careers? Yeah, a lot of hands up, me too. Like, yeah. Amazon S3, another very scalable system, proprietary, except that you didn't have to spend $1 million to buy Amazon S3. You could get into Amazon S3 by spending cents and then scale up as you went. And S3 was a great scalable storage system. Get up to petabytes if you wanted to, as long as you could pay the bills. Then Apache Spark, more memory, like I said, caching-oriented MapReduce really behind the scenes. And then Databricks. So you had this whole progression of big data engineering and web scale data. Now, the reality is that how many of you had to write MapReduce jobs? How many of you did this in maybe Java? Has anyone here used, okay, Aaron. Anyone done it in Pig? All right, do you have maybe you do have fond memories of that. I kind of do, but it was also extremely painful, right? And it turned out that at some point in this era, we realized that most of the stuff we needed to do, maybe not 100%, but most of the stuff we needed to do could be codified in SQL if you had the right compilers to deal with the query. Not everything. There were still jobs that were really complicated dealing with data frames and statistics, but a lot of the stuff we could do just using SQL. And that's where you get into, oh, I was going to mention these things. So some of the things we did in this era, which we're going to loop back to later, text processing at scale, data statistics. And when I say data statistics, data science, that usually meant counting things at scale, right? So even if you were talking at the time about a natural language processing algorithm, that would mean you take a corpus of text, you would tokenize it, meaning you would take like different verb forms and condense them down to one word and just take the verb root. And then you do things like count the different words. And that would allow you to run algorithms such as latent Dirichlet algorithm, which was a way of getting the sentiment out of text just by, as I recall, using a bag of words model. That was the kind of stuff that we were doing at this point that was a bit more sophisticated. And I think when we got to the Gen AI era, we started to forget about that, right? Like that traditional, anything older than 5 years in tech is classical. That classical NLP didn't look so interesting anymore, but we'll come back to it in a bit. Okay, so next era, cloud data and analytics engineering era. So why am I listing BigQuery at first here? BigQuery was not the most influential of these engines. In fact, I don't think too many people knew about it when it came out. But the reason I'm listing it is that BigQuery built this SQL-oriented database, and it was built on top of a storage system called Colossus. And Colossus was basically the successor to what I mentioned earlier, to GFS. It was the successor to the Hadoop-like storage system that Google pioneered. And it ran on a query engine called Dremel. And Dremel was basically one of the successors of MapReduce. In fact, it allowed much more ephemeral compute. It was much more automated in terms of query building. You didn't have to do things like write MapReduce jobs in C++ anymore. It was way nicer to work with. And so they built BigQuery by creating a compiler engine that would take SQL queries and map them into this Dremel engine and run queries on top of Colossus. And so that meant that now, if I had a petabyte of data and I didn't want to build my own Hadoop cluster, I could just push it into Google Cloud Storage and then load it into BigQuery, and I could run all kinds of massive queries on that data that would extract interesting statistics from that data. The development that got more public attention was Amazon Redshift. And that's because Amazon at the time, and still now I would argue, had a much larger footprint and frankly was much better at marketing. And so they came out with a database engine that was based on Postgres, actually. It was Postgres columnar, something called Parasol. And that was one of the first cloud data warehouses that a lot of people got exposed to. And then a company called Snowflake was founded in 2012. And then in 2020, right after the lockdowns had started, Snowflake had an IPO, and it was the largest tech IPO in history in September of 2020. At the time, venture capitalists had a lot of money because interest rates were low, and there was a lot of investment from the government due to COVID lockdowns, and they were looking for something to put their money into. And so they decided to pursue something called the modern data stack. And the modern data stack basically means cloud data warehouse plus associated tools. And so there was a big boom for a couple of years, and then in 2022, inflation was getting hot, and so interest rates suddenly went from almost 0 to 4.5%. There was a big investment pullback, and none of this stuff went away, but the hype cycle kind of died, right? How many of you are using one of these cloud data warehouses in a current job? Yeah, quite a few of you, right? None of this disappeared, but the hype definitely died down a lot. So that's kind of why I'm saying 2015 through 2022, even though none of this has disappeared. Then the final nail in the coffin for the modern data stack, again, it hasn't really gone away, but the hype moved elsewhere, was this tool called ChatGPT in 2022. That came out, and then all of a sudden, that was all venture capitalists cared about, right? Modern data stack was dead. They were all chasing the AI hype cycle. Okay, so now I'm going to talk about some of the things that have emerged from the AI hype cycle. And again, I think you're familiar with a lot of this. I have various citations and research papers here. If you want the slides or anything to look those up, you're welcome to them. Just let me know after the talk. But one of the main cultural divides that you see between data engineering and this version of ML engineering, not all versions of ML engineering, but Gen AI machine learning engineering, is that we care a lot about data curation. How many of you here treat data quality as a core part of your job? It's kind of a loaded question, but yeah, I would say probably the majority. Yeah, it's a completely unfair question. Well, that's fair, yes. That is absolutely true. Yeah, I'm not defining the term. But like generally, if you have the title of data engineer, you probably care about somehow filtering data, transforming data, cleaning up data that is not representative of the reality that it's supposed to be representative of. And we wrote some things defining data engineering a couple of years back when we published this book. But you'll notice in particular that we talk about taking in raw data and producing high quality, consistent information. And so you can think of data as being what your sensor picks up or what's in the web logs, and the information is somehow distilled, and you try to remove garbage results if possible. If someone, well, there are a variety of things that can produce data that is not usable in any way, shape, or form. We try to remove those and then transform the data to make it fit for purpose, whatever we're trying to do with it. Okay, what about Gen AI model training? This is a paper that came out of NIST. You can find it at that link. But the performance of Gen AI text to image and language models scales with model size and data set size and quality. For example, scaling laws indicate that training a 500 billion parameter model would require 11 trillion tokens of training data. Thus, it has become common for Gen AI foundation model developers to scrape data from a wider range of uncurated sources. Now, what does a wider range mean? It means that they take everything that they can get their hands on, including the very dark corners of the internet, including stuff that you would be embarrassed to look at. All kinds of things they will pull because they're looking for as much data as possible. And if you've done any data science, you probably know, okay, if I have a curve fitting model, say it's a polynomial model, the more parameters I have in that model, the higher degree of the polynomial, the more data I need for that model to make any kind of sense. And so that's the core idea here, that just at a base level, you have so many parameters in this model that the more parameters are correlated with higher performance, and you actually have to have more and more data to make those parameters produce interesting results. If you train on too little data, then your large language model will not give you the extra performance that you associate with that higher number of parameters. Okay. And in fact, you now hear discussions of, do we not have enough data on the web to train the next generation of large language models because they're scaling up the parameters so fast that they're basically consuming the entire web in order to train the parameters. Okay, next problem. The way we look at large language models now is what I would call the naive model problem. And so in general, there is an issue in large language models and even other types of generative AI models, so diffusion image models, for example, of them producing highly undesirable things. And by undesirable, I mean things like hate speech. That speech is a tricky issue, right? But in general, we probably, if you ask a model a simple query, you don't want it reproducing, say, neo-Nazi materials or racist materials or a variety of other things that can come out of these models. But the theory right now is that in order to train a model to avoid hate speech, you actually have to teach it a little bit about hate speech. Meaning that if you want it to understand what kinds of things are bad, you need to give it enough exposure to those bad things that it can kind of classify them. So again, that's the approach right now. Scrape everything, suck up all the data in your initial stages of training. Okay, so after we do data collection and preparation, what does model training look like? So up here, this is the stuff that kind of resembles traditional data engineering, although there is this cultural divide. The people who do this first stage don't necessarily call themselves data engineers. They call themselves machine learning engineers, for example. That data, so say I'm talking about a large language model and I just have massive bodies of text, is used for pre-training of a base model. And the basic idea with large language models is you're just training on the sequence of words to predict the probability of the next word. And so you're basically just teaching the model to guess the next word correctly. And that's it. You're not giving it any kind of guidance on how to respond to human queries or how to behave well or how not to reproduce hate speech. It's simply predictive sequences. Next thing we do, and this was one of the big breakthroughs with ChatGPT relative to GPT 3.5, and one of the things that made large language models seem magical and capture the public imagination is what's called instruct fine-tuning. And so in this stage, what happens is you give the model prompts or questions, and then you teach it to respond to those. So in other words, instead of just continuing a sequence of text, you teach the model to answer questions and to produce essays and to produce desirable outputs from the data that you feed in and from the prompt that you feed in. Then we have what's called RLHF. And so that is, sorry, it's suddenly escaping me, but the basic idea with RLHF is that we're fine-tuning the model with actual interactive human sessions. So here, you might do this part just using machine prompts and then grading the outputs in some automated fashion. And then you do this reinforcement learning with human feedback where people are paid to interact with the models and grade their output so that the training can continue. Now, one of the things you may have heard is that people who do this stage are typically not paid well. They're typically in other countries where the wage scale is much lower. And so we outsource that labor, typically outside the United States. And the stuff they have to interact with is often very awful. In fact, they get exposed to all kinds of hate speech and any awfulness that the model has absorbed in its training process. A lot of that comes out here. But the idea in principle is that over time that gets better so that when these models go to the public, they're not producing such awful outputs, at least not as frequently. And then the last part, this is not strictly speaking training actually. This is prompt engineering. So in other words, instead of retraining the model itself, we try to figure out how to ask it questions to do useful things. And we also started applying something called RAG, which is retrieval augmented generation. And so RAG in particular is a big part of search engines that are based on this technology. So like Perplexity, they retrieve data based on your query, feed that in as part of your prompt so that the model is less likely to hallucinate. Okay, so now let's talk about threats to the Gen AI revolution. And most of these are probably familiar to you, but we'll cite them as we go through. So these are in no particular order, But I think we would generally agree that intellectual property risk with the Gen AI revolution is very high. And that's because there are very few rulings. There is very little in the way of relevant case law to determine what will happen when lawsuits are filed, for example, by the New York Times against OpenAI. There are also a number of different questions to resolve, such as what is considered fair use? To what degree is it acceptable for a model to occasionally regurgitate wholesale material that was trained on? To what degree is it acceptable for a model to return pages of a novel that it was trained on? Okay, next risk, hate speech. We've already started talking about that. When you train these models on dark corners of the internet, they learn a lot of bad things, just like kids who are allowed to watch, back in the day, it was like HBO or Showtime a long time ago, descrambled. You don't want your kids doing that because they'll learn bad stuff. That's what's happening with these models right now, and they do still produce hate speech. Misinformation. Misinformation can happen in a variety of ways. It can be in the source data, or they just hallucinate and make things up. Training recursion, I'll explain that in a second. Intentional model poisoning, private data leakage, and hallucination, which is a related idea. Okay. So intellectual property risk, we talked about. This is an example of the kind of headlines we're seeing, and a lot of these lawsuits are ongoing, so they haven't been resolved yet. So for example, OpenAI, without permission, trained on basically the entire corpus of the New York Times, and so the New York Times is not super happy about that. But like, no one knows what the answer here is actually, because there just isn't relevant case law. Is this fair use or not? We can't say at this point. But what I'll add here, though, is that one thing is very clear. If your model is regurgitating a lot of copyrighted material directly instead of just referencing it, that is something lawyers are going to go after you for. And so that in particular is a risk. Okay, hate speech and misinformation. This is an example that was on Twitter a couple months back, but it's not hard to find examples like this, right? So this one presumably is not a hallucination. I would assume that this was learned by scraping dark corners of the internet where you can find all kinds of different conspiracy theories and such. And so even these well-trained enterprise models coming out of places like Google still train on the internet itself. And so they're going to pick up a lot of conspiracy theories and things that we would probably agree are not true. This example is interesting. This was posted right after ChatGPT 4.0 came out. And of course, they've done a lot of work to try to solve these problems. And basically, I think within a day, it was jailbroken to produce very undesirable results. Yeah, and here's an example. This one came out of Canada, but basically using well-honed jailbreaking techniques, they were able to extract things that the model really is not supposed to say. Okay, training recursion. That is not meant to be a reference to the company recursion, but that it's essentially the same term. So here's the idea, the concept, and then basically what this paper does is prove this experimentally. But if I took my phone and recorded an audio signal, so I recorded my voice, and then I took Mariah's phone and she recorded the playback of that, and then she played it back to Aaron, and he recorded it, and then Aaron had played it back, and Sean recorded it, the signal would degrade over time. And the equivalent in the model training world is that you take the output of a model, so say it returns a prompt, and then you feed that back in as training data later on. Well, the basic theory of signal processing says that if you do that enough, the training will actually degrade model performance. And so this was also demonstrated experimentally that if you feed the output back into the model, the performance goes downhill over time. Now, why is this a threat? Well, let's think, for example, about solving coding problems. Right now, ChatGPT is trained on vast amounts of data in GitHub, which is used to basically create the Copilot feature, where you can feed in code, you can feed in coding questions, and you can get interesting code samples that are hopefully mostly correct. But the question is, what happens if 90% of the data on GitHub eventually is not human generated, but machine generated? Well, we can surmise that over time, the quality of the code that comes out of these models that are trained on their own output is going to go downhill. We're not necessarily, well, I don't know what the data says about seeing that at web scale yet, but you can certainly see it in these experiments. And so it raises questions about how these models will perform in the future. Okay, intentional model poisoning. What is this? The idea of model poisoning is to operate at a very large scale on the web so that you can actually modify the model to give a certain type of answer that you wish to create. And so, for example, you might deliberately plant a lot of data across the web to train a model to regurgitate a particular conspiracy theory that you want to promote, or to promote a particular point of view. Now, this might sound theoretical, but there's actually a version of this that's been going on since the early 2000s, except we call it SEO. Well, what is SEO? SEO is manipulation of Google's search model by planting a lot of data across the web. And so this is very feasible, and it's also been experimentally demonstrated in this paper, for example, that if you know what you're doing, even with a tiny amount of data, you can basically poison a model to cause it to put out a particular type of output that you desire, but might not be desirable for anyone else. Private data leakage. A number of papers have shown that if private data, say my personal information, identifying information, is located somewhere on the web, the model will train on it, and it's possible to get models to regurgitate private information that otherwise would be extremely hard to find. And so, last one, hallucination, we'll come back to, but basic concept, garbage in, garbage out. And that's kind of what we're seeing now. Even though we want to train on vast amounts of data, these problems so far have proven to be somewhat intractable. We haven't yet created a model, for example, that cannot be jailbroken. Every model that comes out gets jailbroken fairly quickly, and people can produce a lot of things that these models are not supposed to produce. Now, here's the basic issue. Right now, we do these two steps, and step one, data collection and preparation, does not involve any data curation for practical purposes. Yes, the data form is transformed slightly to make it tokenized and suitable for model training, but we really don't try to curate the type of content that the model is meant to train on, and then we do pre-training just directly on that data. And so what we attempt to do is fix the problems in these models in these various stages downstream. Okay, anyone recognize this frame from an old movie? Clockwork Orange, yes. Aaron, what's happening here? Maybe you can quickly say. He's being reprogrammed to be a good person. And spoiler, I actually haven't seen the movie. The premise kind of disturbs me, but it doesn't work, right? Like after this retraining, he eventually goes back to his old ways. And that's what we've seen again and again with these models, that once they're trained to behave badly, you can overlay that training with various stimulus and feedback, but it seems to almost always be possible to get them to go back to their somewhat evil ways. And that is concerning when this technology is deployed at scale and available to billions of people. So there's that paper. And so again, from my perspective, and I don't think this is an uncommon perspective, part of the issue is that we're trying to do things too late in the process. And that's where I argue that basically at this point, part of the reason that data engineers need to become more involved in the process of machine learning model training, because we need to start deploying things like data curation. In fact, I would argue that data engineers have a lot of different job descriptions, but data curation has always been one of the main things that we worried about. How do I create high quality output? And to Mariah's point, what is data quality? Data quality basically means fit for purpose. So decide what the purpose is. Your job is to prepare it for that purpose. And so in this setting, it involves things like at least reducing the amount of hate speech that these models are exposed to. And so I'll cite Andrew Ng here. You might want to look up some of his interviews and discussions about data-centric AI. But if you read this whole paragraph in this IEEE Spectrum interview, he basically says that for years and years, we've just focused on how we build the model and not on the data itself. And the better machine learning got, the more we shifted our focus in that direction. but we've gotten to the point where we've hit the limit of that approach. And now the data itself needs to be engineered. And of course, that means things like data used to solve rather simple problems, but it also means data at the scale that's used for training Gen AI models. And so that brings us back up to these stages where we actually start curating and preparing data in a more coherent way. And where we collect, we prepare, we curate, but we also input tune. So what I mean by input tuning, this involves processes like evaluating the performance of the model at a given point in time and deciding how much hate speech should this model be exposed to. So like I said, that basic problem of naive models is probably not going away. We probably can't completely train a model 100% avoiding hate speech, but we probably need to reduce the amount that gets put in so that our models are not so tilted towards the dark corners of the internet. And so these are some basic concepts when we talk about data curation. First of all, you have data lineage. How many people have dealt with data lineage here as data engineers? Okay, number of you. And so in traditional data engineering, knowing where your data comes from is very, very important. Now, obviously, on the web, this is a much harder problem than it is in a corporate environment because the data, even though it appears on Reddit, may have originated somewhere else entirely. In fact, you may see it through a chain of possession where it's gone through a number of copying processes to end up on Reddit. But that's where it really becomes about creating probabilistic data lineage processes. And probabilistic data lineage processes amount to doing data science and data engineering at the same time, so that you can determine where this data is sourced from, and if it comes from dark places, then it needs to be suppressed, or at least only injected in the appropriate level. Rich metadata, this is an associated concept. How many of you deal with metadata a lot as data engineers? Great, yeah. One of my friends, Ol Banyu, is working on a book on metadata. But the point is, having data about data is very important in the engineering process. And same thing, that is related to data lineage. Knowing something about where the data was sourced and how obscure the source and associated scores of other data on those sites is going to become more important in the future. Intellectual property risk score. So again, like I said, data gets copied all over the place on the web, and knowing the provenance of data can be very tricky, but at least we can probabilistically score the likelihood that data we collect is copyrighted or copied from a copyrighted source to suppress data that's going to cause intellectual problems in the future. Same thing with hate speech. Misinformation score, machine-generated the probability that something is machine-generated. That is a very tricky problem right now. I mean, it might be one of the dominant problems in machine learning, but determining what's machine-generated, so for example, looking through GitHub sources and determining if something is highly probable to be machine-generated, then suppressing it so we can maintain our code quality as we're training these models. And the idea ultimately is to get to the point where data engineers can assist in the process of feeding models so we can basically tune our models so we're not all the way over here in an unsuppressible way, but we can create models that are neither naive nor evil. And we're kind of in the evil stage right now where we have to suppress some of those more extreme behaviors. Okay, what else? How many of you have done what I would call classical NLP? So basically, again, tokenization, counting words. Yeah, a lot of you. And the truth is this, when I say the return, it's never gone away. Like I'm guessing that a lot of you, does anyone here do this in their job right now? Okay, so some of you. But the point is, this has not gone away. It's still widely used. It's not cool anymore, but I think it's going to be cool again very soon. And I'll explain more about that in a second. But the idea being, how much do you think it costs to run a typical ChatGPT query, roughly? On average. So what OpenAI has said is that they're saying over 60 cents a query roughly is their cost. So basically OpenAI right now is lighting a giant pile of money on fire. If you think about your subscription cost and how many queries you run for a month, even if you don't use it very often, it's probably way, way more that you're spending than they're actually collecting from you. And that problem gets much, much worse if you want to do analysis of actual documents. Like if I'm just putting in a simple query, it might be cheaper than 60 cents. If I put in 20 pages of medical records that I want to analyze, it's probably a lot more than 60 cents. And so that's where, to solve these problems, yes, we'll probably partially rely on LLM models to analyze data and see what might be hate speech, but classical NLP is much, much more economical. And so this technique, I know companies that are doing this extensively for exactly that reason. And it doesn't mean that they don't use LLMs at all, but they use them sparingly and throw classical NLP methods at language analysis because the cost is so much lower when you do this at scale. So check out this talk if you're interested in this in general. So David Talby is a co-founder of a company called Jon Snow Analytics. And Jon Snow here doesn't actually refer to Game of Thrones. It refers to the person who discovered that cholera is transmitted by groundwater by collecting data. And so Jon Snow Analytics is interested in analyzing medical data, in particular textual data, like EMR, electronic medical records, doctor's notes. And they do that using 3 different approaches. They use natural language processing classical. So in other words, they use things like Apache Spark to get sentiment and topic analysis. They use small language models that are very focused on particular problems. And they use large language models to work on problems that won't be covered by the other 2 approaches. And in addition, they're using a lot of agent type approaches where you look at an incoming query and then have to decide what to do with it and maybe take multiple steps to do that. But I would argue that more generally, that they're not the only company doing this. These kinds of approaches are being used elsewhere. And for us to progress with these technologies in a cost-effective way, this is what has to happen. And so that means data engineers have to get more and more involved. Okay, in addition, related to this, this is advanced pre-processing techniques. This goes back to curation that I was talking about. So this means things like fine-grained data filtration, substitution, masking, and randomization, handle private data. In other words, all stuff that you're already doing. You're probably just not working for OpenAI to do it right now, but that is going to happen in the future. Probably most of you don't actually want to work for OpenAI, but you may well end up working on problems related as this technology continues to develop. Okay, next thing, return of specialization. And when I was a physics student a long time ago, I worked in a chemistry lab. I used digital imaging systems, something called scanning electron microscopy and atomic force microscopy. I handled my own chemicals. I built my own systems. And the point is, in the research world, you probably know this as well. You've done physics research, right, Ms. Mariah? Have others done research in a graduate environment? In the research world, we're generally not very specialized if you're at a university. And the reality is that heretofore, large language models have largely been the province of researchers until about 2 years ago when the whole domain blew up. But the other reality is that the specialization has been slow to come. In other words, everyone working at OpenAI wanted the title of ML researcher because that sounds way cooler than data engineer and probably commands a higher paycheck. But as this technology develops, we need specialization, which means that actual data engineers who know things about curating data have to get involved. And this is, I talked about the story of the history of data engineering. If we think about that story, these are the kinds of skills that I think a lot of you in this room have. And some of you are better at some of these and some are better at others, but things like data collection. So collecting data from a variety of sources, both structured and unstructured, databases and the internet, anywhere you can imagine. Pre-processing, data structure and modeling. Modeling has, well, I wouldn't say it's gone out of fashion. It kind of goes in and out of fashion, but the point is that on some level, in your job as a data engineer, you are modeling data. You're deciding the appropriate structure to apply to that data based on what you're trying to do with it. Data quality. So data quality, I think fundamentally we should think about that as preparing data for a particular purpose. Troubleshooting. So troubleshooting can be a lot of different things. It can be, I'm getting weird statistics, what's going on? My system has gone down at 2 a.m. and I'm no longer sending emails for Black Friday. Why is one node consuming doing all the work and my other nodes aren't doing anything? That is a very broad skill, but it's one of the fundamental things the data engineers have to do is locate trouble both in systems, but also in analytics, and solve problems in those domains to get things working correctly. And a lot more of that is going to be needed in the future in ML engineering. Orchestration. How many of you are involved with orchestration here? Orchestration is basically, it's like cat herding, right? It's like taking all these moving parts and getting them to work together in a timed sequence to process data in a timely fashion. And all of these things I'm talking about, when I talk about pre-processing and preparing data for purpose, yes, we need to work with databases. Yes, we need to work with queries, but a lot of it comes down to orchestration to get all those moving parts working together. Understanding distributed systems. So one of the things in my consulting life that I'm seeing over and over again is that people will try to do transactional commits to a columnar database. And what do you think happens when you do that? Has anyone had that experience? Yes. What happens? Yes, it's a disaster. And a lot of your job as a data engineer is to understand those kinds of disasters. It doesn't necessarily mean that you're spinning up your own clusters. You might be if you're running Spark, but at a basic level, even if you're running Snowflake, it's understanding how these distributed systems work so that you can process large volumes of text or run SQL queries in an efficient and timely manner. Classical data processing methods at scale. This includes things like text parsing and NLP, but across terabytes and petabytes of data. And so these are all the data engineering skills that I think in the future will become more and more a part of what we now call AI, but basically machine learning engineering. And these are all opportunities as you're developing your career that you can look forward to in these domains, I think. And that's basically my talk. And I know we've been here for a while, but I'd love to discuss a bit with you if there's time, what your opinions on these things are. So.
I'll do it. I mean,
yeah.
I'll do it. I'll take it.
I can use this. I'm sure everybody can already hear me. But so what is the general thought behind, I mean, you mentioned, like, is there even going to be enough data on the internet to even train the next generation of these models?
So that is a very good question. So yeah, basically, I'll have to dig up the quote, but I've heard that from multiple places that they're basically OpenAI is saying, well, even if we scrape all this data that people don't want us to scrape, like the New York Times, like copyrighted material, like hate speech, there's not enough text data there to justify larger models, even though we can scale up to that size, and we theoretically could see performance improvements by doing so. That's related to another idea that I didn't talk about much here, but I think data engineers will be involved in the future, and that's what's called data augmentation. And the core idea is, so of course, in the modern era, deep learning has been around for a long time, but in the modern era, deep learning really took off with image recognition. And one of the things that machine learning engineers figured out fairly early is that if you had a bunch of images that you were training a model on, you could augment that data quite a bit by rotating the images by arbitrary angles and by rescaling the images, because a cat should be a cat at 30 degrees or 0 degrees or minus 30 degrees, whether you scale it up or not, as long as you have enough field in the view for the model to pick it up. And so I think part of what we'll have to figure out is how to augment text data. So in other words, how do you take input text data and make more text data that's actually valid if there isn't enough data on the internet? Now, that seems like a hard problem, and I don't know how we'll get there, but I suspect that we'll figure it out eventually. Partially, yeah. So yeah, go ahead.
Well, no.
Okay, yeah. I think, yeah, the question is, how do you augment basically without it just being recursion, without it just being more output of models, right? Because if you, I think at a base level, the assumption is that more and more of the content we see online, more of the text content is being produced by these models, but can we augment in such a way that the output is high quality enough that it's more like rotating images, where it's still valid data that's not going to ruin the model training process?
What was the word? I forget the word. See, I had this
Oh.
conversation. I had this
Okay.
conversation not like literally a week ago.
I mean, you're basically assuming one majority, more than majority of people are two people.
Yeah.
That's not how the world works.
Yeah, I don't assume that at all. And that's where I sort of see,
So-
yeah.
I was talking about this with my friend last week. He's writing a book on LLMs.
Yeah.
And so he was talking about using context-free grammars essentially as a separate path. So anyway, it was in relation to my Twitch bot that I have running on Llama 3.1, but I'm self-hosting it because I don't want to pay for anything because I'm cheap. Anyway, so if I want to be able to create something that's slightly random but still has a format, context-free grammars is essentially how Alexa and Siri and all kinds of things have been doing that in the past. It's just a classic NLP style thing where you can say, hey, the sentence will have form X plus 1 plus Z, and where each of those is a certain type of thing. And so it gives your model the ability to inject synonyms or certain kinds of, fluidity in the words that it says, but it has to be an exact formatting. Yeah.
Yeah, but that's assuming you're gonna do that. Nice job of using your context-free grammar. I'm gonna do the opposite. I'm gonna go and build the adversarial component to that, and I'm just gonna generate bad stuff everywhere with tons of hallucinations. I mean, it's already being done, so.
I mean, yeah.
I mean, who's gonna, and if you look at the proportion of good and bad out there in the world today, there's not gonna be a clear winner. It's just gonna be a perpetual, angels versus devils all the time. So,
I mean,
and the thing is, we might already be too late. I mean, I wrote this down, has the ship already sailed? I mean, are we to the point where people has enough technology, they're bad actors, and just go out there and do whatever they feel like to populate the data that we're going to be training on already?
my opinion, that's the reason why OpenAI has 1,000+ employees, is because the model is so far gone that they have to put rules on top of it to clean it up. Like that's the opinion. I've never talked to anyone that worked at OpenAI, but yeah, we can't trust these models as far as we can throw them. So we put rules on top of them to then, try and make it socially acceptable. So yeah.
Yeah, but that's playing defense, right? And
I-
you know that in cybersecurity, playing defense is a losing game, right?
I agree.
Is the newest version of OpenAI use a fundamentally different architecture? I don't know if I've read something about this.
It's an agent architecture, basically. So
Yeah.
the idea is that instead of just responding to a query, it actually, as I understand, I mean, they don't reveal the details of how this works, but based on other research, it looks like the model probably comes up with a plan and says, okay, I'm gonna do X, Y, and Z to solve this problem. So for example, they try to demonstrate that it's good at solving mathematical problems. So say, okay,
Yeah, well,
break down.
not giving that to the model.
Oh,
Yeah.
If
So-
it recognizes it's a certain type of problem, it can access.
That's what I'm
something
saying,
that's
but it's the
already
rules
prepared
on
for
top
that.
of the model that are giving it security, not necessarily, yeah.
Yeah, and obviously it takes longer as well.
It takes longer, it's much more demanding, they may be using multiple models together. But that's kind of cutting edge right now is the agent-based approach, meaning that you have either multiple models working in concert and one model that's given a number of different tasks that is meant to sort of be a check and balance against itself. So that's another thing I didn't get into here. I think it would be very interesting to see where that approach goes. You can imagine it gets even more expensive and even slower than it already is, but maybe there's some hope.
Oh gosh, we got so many questions. Here you go, Aaron.
So Matt, I have a little bit more down to earth question. You were saying data engineering is needed up top. Like if I'm doing like classical machine learning, I'm agreeing like, I want to start with the raw logs. I want to write some Spark scripts or something, or God forbid, a MapReduce script in Java to run on Hadoop. I don't know, whatever. Right. And I want to parse that into something and I want more control over it. We want to curate it and things like that. And like being in ML ops, right? I like to think that, I'm really cool when I do that stuff like that. But we're working on like risk models for leases. So I would say in the like AI world, these are like go-karts, right? Um, these LLMs aren't even, you can't even, they're not even F1 cars compared to go-karts. They're freaking rocket ships, right? Where if who, how many people are actually, there's 1,000 people at OpenAI, right? I mean, Overstock.com had 2,000 people to run a website, right? We probably had a bigger data engineering team than maybe OpenAI did. I don't know, right? Maybe they have all that. But I guess what I'm saying is if you're in that LLM world, you're a baller. Like you have a nuclear power plant to power your data center and you're scraping all the data in from here to Pluto or whatever, right? Maybe you're collecting it from the Mars rover for God knows how much, but like, what's the reality that data engineers are actually going to get into like Meta or like ChatGPT? I guess Elon Musk wants his own LLM now. It kind of reminds me of the Bitcoin craze where everyone was starting their own coin. Now all the ballers want their own LLM or their own rocket, right? How realistic do you see that data engineers are actually going to make it into those types of specializations? Because I feel like it's a very small pool with a very large amount of money, right? Versus like most data engineers I know are just like writing DBT and Airflow, right? So
Yeah,
can you tell me like what the plan would be to kind of like do that?
that is a good question. So what I hear from people who were kind of in that Bay Area circle or other circles close to these models is that the people who work at places like OpenAI are both very brilliant and very naive. So in other words, they're very good at basics of data parsing. Go scrape the web, grab all the text, feed it into the model. But they're very bad at basic skills like, well, what used to be basic skills for data engineers like classical NLP or data filtering or a lot of other data preparation. And in fact, their incentives are scrape as much data as you can, feed as much data as possible into the model, and that's it. Don't touch it. Don't change the data, just tokenize it and feed it into the model. Basically set up a fire hose going from the web into the model to train it as quickly as possible. And so that's where I think we're probably already headed toward the backlash where data engineers are actually called for and required in these jobs. Now, as far as actually getting into one of these companies, that is another tricky thing entirely, right? That comes down to a lot of details of Bay Area culture and such. But I think we'll move beyond the point where model training is quite that naive, where there's no concern whatsoever for what you put into the model. And I think the people who are involved in that will be called data engineers. Will it be kind of a new iteration of the data engineer job title? That I'm not sure about. So.
Think, right, to be devil's advocate.
Yeah, no, please.
I can't even get a company of 30 people to care about data quality. Right? Like data governance. Like I used to say, data governance is like Marxism. It sounds great. Everyone wants it. No one has it. Right? In colleges, right? I don't want Marxism, but I'm just saying, right? It sounds good on paper. No one has it. I've never been at a company that actually has good data governance. Right? You just said this model is so far gone. Like if you put data engineering and curation on it and now it slows down the project by 3 years, you know what I mean? Because like that's what I've seen at every small company. That data quality slows down everything. So they don't do it. Right. So do you think that it's realistic that kind of coming back to the bad actor scenario that these companies are actually going to slow down? If this was to help, that they would slow down and do it, right? And if it was going to cost them money.
So I think what I think will happen, and maybe I'm being naive, just like you're saying, that is quite possible. But I think we're getting to the point where the public backlash and political backlash is going to be so strong that companies are forced to act, basically. Now, to your point, with the traditional tech industry, places like Facebook and Google, and issues such as data privacy, It took about 2 decades for that to happen. Like they were basically able to ignore a lot of those issues from the late 90s into the late 2010s or early 2020s before they had to actually take that data privacy seriously. I kind of think that the visibility of these issues, where every time there's a model release, someone jailbreaks the model and shows how terrible it is, I think this will become a significant political issue in the future. And then it's a tension between regulation of businesses and the government and, free speech and so on. Like, will the kind of anarchic tradition of Silicon Valley win out? Or will the government finally say, no, if you're doing this, you have to pass these tests or your model is not allowed to even be out. It's not a question of liability. We won't even allow you to do this. And then will there be a significant difference between, say, Europe and the United States, which has traditionally been the case with data privacy, for example? But you may be right, too. Maybe I'm being completely naive and this is simply not possible. Yeah. I think it's a valid question. I think these are very valid questions. Yeah.
And I find myself in data governance after being kind of everywhere else. And the only people who really care are regulated industries, right? Insurance, banking, government. I mean, government is spending a ton of money on data governance right now. And they're trying to figure all that out. And like my company, I mean, we have 600, I'm at Elation, if anybody knows that. I mean, we've been around for 10 years, industry leader, and like all the customers that are doing anything are massive banks and massive government. And yeah, they're being forced to do it because of the industries that they're in. But like, we don't sell to, like, Salesforce just dropped us like a rock because they don't need it. They're not regulated. They don't care.
Cool. Do one more question. We'll do yours.
Thanks. Yeah, so I was gonna kind of slide it into almost like a two-part question, but so when you talked about some of these opportunities for data engineers, a lot of them was around kind of like, okay, some of the like NLP processing or around aspects of like content scoring, risk scoring, threat assessment, and things like that. And I think like to an extent, you can think of them as I mean, there's a data engineering component in the more classical sense, but at the same time, there's also a large like data science and modeling aspect for a lot of these kinds of pieces. And so like, and I also don't know too many data engineers. I mean, there are some, but who are like very deep in some of these like sub areas, like things like NLP. Like, I feel like there are more data scientists or machine learning engineers who have that like expertise, or they did a lot of work in their PhD in that area, and then they can do also the data processing. So like, is this kind of like more of a like, it's an opportunity for data engineers to sort of like, or future data engineers to reinvent themselves? And then like, so the second part was also like, these are very certain common things across like a lot of data. Like, to what extent like have some of these things become commoditized or becoming commoditized for like, as like reusable kind of components for doing these things, like same way that you would have like common operations in your Spark SQL, that you just basically have like common operations for doing these sort of like document like accuracy assessments and things like that automatically.
So to your first question, I think you make a very valid point. And I think what we'll see there, not every data engineer, like not all of us, you can't learn the whole world, right? Like there has to be some level of specialization. I think at the big FANG companies and the heavy hitters that, like Aaron said, are building rockets, what you'll see is data engineers working very closely with data science and ML engineers to build systems that solve some of these problems, and also much, much more power efficient, because the bills will just become too large at some point. I think part of what's likely is that just like we had a dot-com bust, we'll probably see an AI bust. And that doesn't mean the technology is not going to stick around, but it does mean that budgets are going to tighten substantially. And that's part of what will motivate this shift. But to make it happen, to your point, you'll need data engineers, but you'll also need the data scientists who are saying, okay, this is the NLP algorithm that we're actually using it. Go implement it at scale. To the question about commoditization, the funny thing is this is a part of data engineering that so far doesn't seem that commoditized, but it might get commoditized in the future. I think that the parts of like building massive cluster systems and compiling queries and those kinds of things, those are largely commoditized. You just go use Snowflake, BigQuery, whatever. But I think NLP questions at scale, oddly enough, that's still, I don't know, what do other people think about that? But that still seems to be a very particular specialization that if you develop at least enough to work collaboratively, there are career opportunities there. Yeah.
I mean, I think a lot of those, with your reference to like NLP, I think a lot of those services are available like via APIs now. So I think there's a difference between like a data scientist who might be needed to make a new NLP, like custom fit for a specific business versus like kind of a out of the box thing you can just use an API. Like I used Microsoft Azure AI image recognition thing for something just via API, and that worked great.
Well, there's probably a difference between like what you would do with scikit-learn, for example, in Python, where it's out of the box NLP versus I need to do this across my like multi-petabyte web scrape in the most efficient way possible because I'm spending, hundreds of millions of dollars on processing, and I need to get that scaled down as much as possible. So that seems likely, but yeah. Thanks for everyone for coming. Like Aaron said, I may be extremely naive. He might be right about that. So maybe we'll be talking about this, Nick. It's quite possible though.